All right, we are up and running, it looks like, at long last. So sorry about that when I had another issue with the stream. So some tweaks around that particular to come up or down, barring that you can adjust your own audio, your own levels appropriately. Cool. So, learning list, you have a collection of objects from the left to the right, and you just count up index list. Let me just find. Oh, wow. Okay, excuse me. When it rains, it pours, right? One issue just kind of leads to another. Okay, cool. So let's actually just look at a list. I have a list. I'm just going to create a variable list. We have to refer to lists, so we don't want to override that. Python, unfortunately, will just let us do this. It'd give us an error, but unfortunately it doesn't. One of those built-in things that you have to remember to not over. People are like, oh no, I'll break my Python install forever if I do this. You'll just break the running of the program that you're running, and then you just delete it. It doesn't like alter your Python install if you make that mistake. It's just may cause unexpected. We can just fill this up. That'll right. So I can put numbers and strings and integers and floats and booleans. Okay, I think you get the picture. In which you might think, well, that's a given. Why would not all it is order? We start at this first item, that's going to be index 0. The second item is going to be index 1, and the third item is going to be index 2. So if I ask for so there are other types that need to index, tells you that something. So I print this out, and the element that we're for. We can also slice of the list or a section of the list. It'll give us a short little range of the elements here. So I'll start at section is going to be where the index starts. The middle will be where the index stops, where the slice stops. And stop step pattern at a stop. So we'll say that's 1, 2, 3, 4. So I can put 4 there. So I wanted hello through true. So I got hello through 3.5, which stops short. So this true is exclusive or exclusive. I'm going to include it. Variable called foo equals 4, which is the index where we want it to stop. So we'll say foo plus 1. So how to, there's data out there to do it, but not often. We can retrieve a single item from the list for the second index in that index. So this is a number. So when I multiply it by 3, and that'll be whatever 57 times 3 is, 100. So this is just so I don't have to go search for it. Flow. Okay, I'll look. Okay, so named depends on the type. Excuse me. On the data types. So we want to test iRelief in it. Boolean string float net. Okay, good. So here's a Boolean value. We'll say true. 3.7 and so let's see if we get an error now. Probably get nothing. Good. We get none returned from all these functions. That's what we expect. If you were in Premium Prep the other day, this is a good example of how to use pass, right? I can like build up some of my tests real quick and just make sure like, all right, cool. So what the function returns depends on the data type of the object. Okay, so 0 if object. Okay. So we have to have another case for the int being 0. Okay. So in this case, we want the function to return 0. Oops. Yeah, okay. If it's even, so we'll say elif if the 1.5 string concatenated with itself, if the object is a bool, return the negation of that bool. So if it's true, then return false, none. Okay, that's easy. The function will just return. Here, it would return E54. This will hello. Like we place as I write, they kind of check them off. So, and then we're ready to actually write some code. Trying to show y'all like good workflow habits that are going to help you succeed. This I am taking longer because I'm doing the workflow and kind of talking about it as well. So let's give this a shot. So we'll say if type equals 0, I'm getting some little bit. See what we can do real quick here. Yeah, I can. I'm just gonna try to so something more. That's good. Okay. If the type of the object is a float, float, and that'll actually concatenate it twice. So that looks right. Let's do 3. So if the type is a bool, we can return not obj, right? Because not inverts a bool, so we can just do that. And then if the type is none of those, we're just going to return none. You just get a working solution out. You have your tests. Just get it passing the test. This is sort of, these are not nuanced tests. Try to get all green, get them to pass. If obj is an int or a float, multiples of these. The elifs, which is what, but it did state that explicitly, so I'm going to code for it explicitly just to round things out. Cool. Okay. So let's see what that other solution I had was. I'm just curious. I had solved this, I think, a couple days ago. This is what I had before. We check if obj is the same as all the type specifier name. We could say and then same sort of thing. Cubed, that helps. Let's submit that. Make sure it actually does work. That it'll actually pass the formal. Gosh, I'm really sorry to talk a little bit about list. Getting a section of the list returned as a list. Let's talk about the mutable methods. So there's a really IR. Give me print dir list. This is gonna print the directory of this list. Oops, excuse me. LI method that is declared for list. So now, look at each one of these. Most beneath this, remember the integer 5, not 5 elements. Okay, slicing and indexing doesn't change the integer 5, not 5 elements. Okay, slicing and indexing doesn't change the value of the list. Append does change the value of a list. If I print out the value of append, think about this. What's this value going to be? What do you assume it's going to be? The copy of the list with the append returns none. It's not useful for its return value. It's useful for the operation that it performs. Okay. Let's not do it that way. Let's throw it in a for loop. We'll say for num in range. We will append num to the num to the square root of num. And I'm just doing this to just have a random operation, not necessarily the formula here is not important. It's just a random formula. So we're raising the is none. The reason I make this, I'm saying this in the way that I am, is because I see people make this mistake a lot, and it's fine. It's an easy assumption to want to Python. Let's do that. I curb that habit, I promise. Yeah, okay. You can probably imagine what this one's going to do if I print list under this. Again, this is a mutable method. It doesn't return something. Actually, I don't know that for sure. I'm assuming that, but I'm pretty sure we're going to get none. That gives us none. This shows us that clear doesn't return anything. It doesn't return an empty version of the list. So because object that they're being list two are now two different, which will show us that the numbers are different. So we have the top tell those are different IDs here. And then we print their values. Actually, let's do those on one line so it's clear. List one. Let's reduce the size of this. Let's just go for the first one, but it did not. And see why copy is used for list. I keep calling it list one, but I think you know what I mean. I have a identifier called list two at the same what I do. Let's do list.count and two U's, and we have this hello. And let's get the count of our example of a method that is not a mutable method using count. Us have list our numbers in the beginning, and then all the elements with extend. I have one list with no nesting, so that can be useful sometimes too when you want to combine lists. Index. I count and index. Yeah, okay. This again, we'll say list. We'll take this list again. So we'll say list.index how. Of course, I need to print my list as usual.